Okay, let's finish our review for the review test by looking at these problems. It says find the solution each equation from the set -4, -2, 0, 2, 4, and 6. Now those of you that remember from your algebra days, your algebra 1 and algebra 2 days, that typically when we are solving an equation we don't have a replacement set this small. We usually have the set of all real numbers that it's defined for. But in this case I have these 6 numbers and I can pick my answers only from these 6 numbers. Now in chapter 2 we're actually going to review solving one-step and two-step equations like we have here. They don't want you to actually solve this equation by subtracting 5 and then taking the opposite of both sides, or over here by dividing both sides by -4. What they would prefer you to do is to plug the numbers in one at a time until you get a true statement, because by definition your solution is the value that when you replace the variable by this number, it gives you a true statement. So I think most of you would be probably in agreement with me that if I plug 4 in here, this is the opposite of x. So if I plug 4 in for x, I would get the opposite of 4 plus 5 equals -1. Well, does this give me a true statement? No. This gives me 1 equals -1. No good. As it turns out, none of these numbers from -4 up to 4 work, but when I plug 6 in, I get the opposite of 6 plus 5 equals -1. -6 plus 5 is -1 equals -1. It works out okay. So the solution here would be x equals 6. If you get a false statement, it's not a solution. If you get a true statement, it is a solution. Now, I'm not going to plug in a bunch of numbers in here that are going to make this false, but I think you'll agree that if I plug 4 into this one, now remember, -4x means -4 times x, so this is -4 times 4. Does that equal -16? Well, as a matter of fact, it does. -4 times +4 is -16. This is a true statement, so my solution is x equals 4. Now, again, you're probably looking at this. I knew this already. I would just divide both sides by -4. Well, I'm just showing you that by definition, if they give you a replacement set, you plug the numbers in and look for the values that make it true. Of course, we can use the shortcuts to help us out. Now, in these next two problems, it says find what it's worth, how much it is. Evaluate each expression given that x equals -3 and y equals 6. So this is sometimes referred to by old timers like me as plug and chug. You plug the numbers in and you grind it out to see what it simplifies down to. So in this first example, I have 5 times x, which is -3, minus 3 times y, which is +6, but that +6 is squared. So I do the exponent first. Don't multiply and then square. Take the exponent. So I have 5 times -3 minus 3 times, now 6 squared is 36, 6 times 6. Now I'm going to multiply these two numbers. That's -15 minus 3 times 36. Then I'm going to multiply these two numbers. And I get -15 minus, well, 3 times 36 is 108. And a -15 minus 108 is the same as -15 plus -108, which is what, 123? Didn't give myself very much space there, did I? So you substitute them in, then you use your order of operations to simplify. Same thing over here. I plug the -3 in for the x here and here, and the +6 in for y here and here. So I get 2 times -3 plus 3 times 6 all over 3 times -3 minus 6. Plug the -3 in for the x, the 6 in for the y. I'm going to, again, the fraction bar kind of separates it into two parts. Now, order of operations says you multiply and divide from left to right before you add. And I have two multiplications, but because they're separated by the addition, I can do both of them in the same step. So I get -6 plus 18. And on the bottom I have 3 times, now -3 in the parentheses, you have to do that first. -3 minus 6 is the same as adding the opposite, so that's a -9. So I have up top, I have 12, and on the bottom I have -27. Now that's not a terrible answer. I don't really like the negative in the denominator. I like it either in the numerator or out in front. But I noticed that I could divide top and bottom by 3. 3 goes into 12 4 times, 3 goes into 27 9 times. So I have 4 over -9, or -4 ninths. It just looks nicer. if you put the negative out in front. If you have to have it in either the numerator or the denominator, probably more traditional to put it in the numerator. Now these next couple of problems are story problems, and from the story problems you have to kind of read to see what it wants you to do. Look for key words, and I'll point out a couple of them here. It says the highest elevation in the continental U.S. or in California, approximately 88 miles apart. Mount Whitney is at 14,494. This little tick mark means feet above sea level, while, not white, while the Badwater Basin in Death Valley National Park is at an elevation of 282 feet below sea level. You are to find the difference. Difference means subtract between the highest and the lowest. So the highest is 14,494 feet minus, now because this is below sea level, I'm going to write this as negative 282 feet. So remember, subtracting a negative is like adding the opposite, so I'm going to add those numbers together, and I get a 6, and I get a 7, carry a 1, and I get a 7 and 14. And that would be the difference in those elevations, 14,776 feet. So the problem is longer to read than it is to actually work out. Similar in problem 20, it says for a certain system of rating pitchers, 4 points are awarded for a win, 3 points are awarded for a save, 1 point is subtracted for a blown save, and 2 points are subtracted for a loss. If Joe Horner has 6 saves, 4 wins, 1 loss, and 2 blown saves, how many points does he have? Well, Joe Horner used to be a relief pitcher for the St. Louis Cardinals back in the late 60s, early 70s, and 6 saves, and it's 3 points for a save, so it'd be 6 times 3. And 4 wins, and there's 4 points for a win, so that I'm going to add to that 4 times 4. But now he also has 1 loss, so I'm going to subtract 1 loss here. 1 loss is 2 points subtracted, so that's, since I already have the subtraction here, it's going to be 1 times 2. And I'm going to also subtract, he has 2 blown saves. It's 1 point subtracted for a blown save, so I've already got the subtraction, so 2 times the 1 point. So this is going to give me 18 plus 16 minus 2 minus 2. 18 plus 16 is 34, minus 2 is 32, minus 2 is 30, so he has 30 points. Now, this is a multiple choice test that you're taking. But if you were to be wanting to turn something like this in on paper showing your work, on story problems, remember you should always write your answer in a short sentence. Like, for example, it could be something as simple as Joe Horner has 30 points. Because typically a story problem demands that it be answered in words, as if you were talking to someone. The average American annually for the year earns $74,664 and yearly spends or annually spends $83,225. See something wrong here? Write the average American net deficit, because we have a deficit here, as a signed number. He's making or she's making $74,664, but spending $83,225. Now, if you wonder how that's possible, I would suggest that maybe you speak to my wife, but it's possible because of things like credit cards and borrowing money. So now, this is the same as adding the opposite, and I get, ooh, this is going to be a messy one to try to do in my head. So 83225746664. I subtract the smaller absolute value from the larger absolute value. I get 1658, negative 8,561, and we'll put the dollar sign on there, dollars. So again, if this was a problem that you were going to turn in for credit, you would say the average American net deficit is negative $8,561. Doesn't speak very well for people spending when you see that. Now, the next 5 problems are matching, in that they give you 5 properties, 5 very important properties in algebra, and examples, and you have to match the example with the property. Now, students forget what some of these properties mean, so this is a good time to review it. But there are things that you can do to help remember. Like, for example, commutative. The first two letters of the word commutative, CO, I always think of it as change order. When you add or when you multiply, you can change the order. You get the same answer. 5 plus 3 equals 3 plus 5. 5 times 3 equals 3 times 5. So the commutative changes the order. The associative, to associate, means to kind of group together. All right, so you'll be looking for grouping symbols to help you identify that. And what it says is if you're adding or multiplying three numbers, it doesn't matter if you add the first two first and then add it to the third one, or you add the last two first and add it to the first one. Same thing with multiplication. So it's the way it's grouped together and associated. The inverse, I think of reverse. The inverse just undoes whatever you started. For example, inverse, when you're adding, if you add opposites, you get 0. They undo one another. If you multiply reciprocals, you get 1. They undo one another. So we have to look for something that undoes. Now, whereas the identity, that's like the 0 and the 1 for adding and multiplying. The identity just says you add 0 to a number, you just get that number right back. Or you multiply by 1, you get the number right back. So you get identically right back to where you started. The distributive is probably the one that we use, I'd say, the most, especially when we're simplifying expressions. The distributive property is where you eliminate a sum or a difference by multiplying through by a factor out in front of the parentheses through the sum or through the difference. I'll show you which ones match up here, and maybe I'll point that out a little bit better. Now, the commutative one is actually kind of a tricky one because they didn't change the order here. There's no 1 written down. And 3, 5, 7, 3, 5, 7, they didn't change the order there. And no, they just got rid of the parentheses. But look right here. The 3 and the 5 are in the parentheses. It's times the 7. Then it gets reversed. The 7 is times the 3 and the 5 in the parentheses. So it's actually answer D. That's the commutative property. Even though it's a little, kind of goofy looking with the parentheses, it's trying to fake you out a little bit there, maybe make you think associative. You can just change the order of what you're multiplying. Remember, the commutative property works for multiplying and also for adding, but not consistently for subtraction or division. The associative property, remember, to kind of group together, so I'm kind of looking for parentheses, and I stop here at B. 3 times 5 is multiplied first, then times the 7. Or here, the 5 and the 7 multiplied first, then times the 3, because the parentheses tell you what to do first. That's this guy straight across. The associative, and this works for addition as well, the associative property, the order stays the same, but what you multiply or what you add first doesn't. The inverse, we're looking for something that undoes one another. Well, look no further than E down here, because you're adding opposites here and you're getting 0. The negative 7 plus the positive 7 cancel one another out. The identity property is when you're either multiplying by 1 or you're adding 0, and I'm multiplying by 1 right here in example A. 5x times 1 is 5x, so that's an example of identity property. You get identically right back to where you started. And everybody's favorite, the distributive property. The distributive property, typically we will have a factor out in front, sometimes even in the back of the parentheses, that we are going to distribute over the sum or difference. In this case, a sum. 2 times the x plus 2 times the y, written right here. And this is a key property because we use it a bunch. We're going to use it right here in problem 30, and we're going to talk a little bit more about it here in problem 27. It says which property is used to clear parentheses, to simplify. That's the distributive property. A times the quantity B plus C is equal to A times the B plus A times the C. You eliminate the parentheses and then hopefully you can simplify. Now, problem 28 is a little bit of a goofy looking problem. It says simplify this expression 2 ways. Well, one is order of operations. You do the stuff in the parentheses first, so that would be, or in the brackets first, so that would be a positive 3, and then you multiply. The other way would be to use the distributive property. By multiplying through, I have negative 6 times 5 is negative 30, plus negative 6 times negative 2 is positive 12. Negative 30 and 12 gives me a negative 18. Now, I actually like the first method a little bit better because it's a little bit faster, but that's because everything's a number. If there were variables mixed in, you'd want to go with the distributive property. Now, just like, and I think it was in our first video, we added some fractions. We had to have common denominators. You have to have like denominators. That happens a lot when you're adding. When you're adding decimals, you have to have the like decimal place values lined up. You have to add ones to ones, tens to tens, tenths to tenths, hundredths to hundredths, and so on. Well, and when you add fractions, you have to have like denominators. Well, when you are combining expressions that have variables in them, they have to be the same variable. They have to be like variables, and that's exactly what I have here. That's supposed to be a 3 there. I have 3x plus 9x minus 8x plus x minus 6x. They're all like terms, and I'm going to put a 1 right in front of this x that doesn't have a coefficient, because 1 times x is x. That's the identity property. And I'm going to just add these numbers that are in front of the variables. Those are called coefficients. So I have, because they're all x's, so I have 3 plus 9, that's 12x, minus 8, that'd be 4x, plus 1, that'd be 5x, minus 6x would be negative 1x. And that would be a good way to write the answer, but even cooler would be, because we know 1 times x is x, would be just to write the opposite of x. That's probably what you'd be looking for if you were doing matching or if you were doing multiple choice. And last but not least, I have some distributive to do down here. It looks like I only have 2 distributives here because of the 3 in front and here because of the 2 in front of the parentheses, but I have 3 because even though there's no number written down in front of the parenthesis here, it's as if there's a 1 there. Now normally I wouldn't worry about a 1 if it was a plus sign, because that's positive 1 and 1's the identity element for multiplication. You're just going to get whatever you multiply it times. But that's a negative 1 because of the minus sign. So I have to treat it like a negative 1. So I distribute here 6x plus 9. I distribute here, that would be the opposite of x minus 7, or minus x minus 7. And then I distribute it here, and that would be 2x minus 6. And I'm going to simplify this by not only getting rid of those parentheses, but by combining my like terms. Here they are. I like to underline my like terms like this. And these are constants, so they're like terms. They don't have a variable. So I have a positive 6 here. This is like a negative 1x right there, and I have a positive 2x. 6 and a negative 1 is 5, plus 2 is 7x. I have a plus 9 and a minus 7, that's 2. And a minus 6, well 2 minus 6 is negative 4, so I'll write minus 4. And there it is. Now this hopefully will help you get through any difficulty that you might have. I know that the videos are long, but because it's a test and it's worth some serious points here, I figured I'd go ahead and make sure that everything was explained in detail. And hopefully this will help you get ready to take and finish up that test.